Hi, welcome to part 5 of the AI Guard tutorial, and so we're going to be adding a few features this week, and I thought I'd run through some setup stuff with you first. So it's basically the same setup as we had before. What I've done is I've copied this character blueprint that I was using for my player character and called it enemy character and dragged one of those out into the world. So there's a couple of things that we need to sort out. One of them is this, the guard itself. I've noticed that there was an interesting little issue with the perception system when I started adding the enemy. Because the enemy itself I set to have an AI controller essentially. It doesn't actually do anything yet, but that's to come next with the mob AI. So I noticed that this guy wasn't sensing him. So if we go to the guard controller like we did before and go to the components tab, you'll notice that in the list of AI things for the pawn sensing components, if you click on that, I had this set which is only sense players. So basically it needs a player controller on the object before it'll sense it, and obviously because I was using an AI controller instead of a player controller, it didn't see it as a thing. So if you get any problems with objects not being sensed, that's one potential problem. So it could be that you need to uncheck that box. So just check that when you're doing your setup. There is, however, another problem which is kind of peripheral to that. So if I run this example right now, what I've done is I've moved my start point over in the corner, and I've set the character over in the sort of enemy character to make a noise every, I think it's every 5 seconds or something. So the guard sees, hears the noise, comes to investigate, sees the guy, and does him in, essentially, which you just saw there. Now then, that's running in when I'm running a character. If we do the exact same thing when I simulate, so the guard's running over there, he sees this enemy, but then somehow doesn't manage to sense run the hearing senses. So I think that that's probably a bug somewhere in the Sentry system. I will have to check that out and post an update to this video when I've figured it out what's going wrong there. But for now, we just need to possess a character when we test the engine. So something changed when there is a player controller in the world versus when there isn't, which is a bit of a problem. But let's not worry about that right now. So, as I said, this enemy character is meant to just be a placeholder. He's just something there to be hit by the guard, essentially. And what I've done is I've taken the character controller for my character. So remember we made the my character thing, so it's got the health bar and all that lot. Well, I literally just did a copy and renamed the copy to enemy character. So there are a couple of little changes. If I just drag that window onto here, there are a couple of changes that I did to that. So I'm handling the damage events like I did before. One thing I have added is, so normally we went sort of print string and then checked the validity and updated the UI widget. So I've added this sequence node in here so that after it's printed, we still do the UI check even though we haven't actually got a UI now. We then do another action, which is essentially to basically say if health is less than or equal to 0, destroy the actor, which is why the thing goes away. So that's just a simple thing to get rid of this character when the guard kills him. So any damage, takes the damage off, prints out what the damage is, and then essentially kills the guy once the damage is less than or equal to 0. The other thing I've done is I've stopped it from creating the widget, which is useful. I like to do this where I've got an event and I break it down into a sequence of steps. It's basically like a sort of if well, it's basically like a number of function calls, one after the other. I just like to do it to sort of essentially so I can stack the boxes one on top of the other when I'm doing a blueprint. So the next thing I do is when I get an event begin play, we don't really need a sequence node in, but I'll leave it in so I can just connect back up the UI if I need to. Set a timer, and here's an interesting one. If you do the set a timer, it's a looping timer, so it'll keep looping forever. The 5 is the 5-second delay, and it says the function name, right? So if you go to add custom event, and you can give an event any name you want, and then type in the same name as the event. So essentially this function, this timer, every 5 seconds will call this custom event, and the custom event does what I used to do with the F key, which is make a noise in the world. Now one thing you should note is that there is a little bit of difference here in that I used to drag this node into the get location, and what was actually happening was that the actually this doesn't really need to be that either. We could ignore that one if we wanted to, but it doesn't matter because we're not actually using the instigator. We need to get the actor location. What I was doing, I was getting the player pawn and feeding that into the get actor location. Obviously the player pawn in this case would be the character I was running around with and not the enemy character, so you need to break that link here if you've got one. So basically what you're doing is you're feeding the actor location of the enemy character into the location to make the noise, and then just calling play sound at location as it used to before. So a pretty simple setup for that one. It just means that we've got something we can place in the world that will hopefully make our AI react to it and react to a noise. So so you can test both sense types essentially, which is what I was after. So what else have we got? So as it was before, there is a question of there was a couple of things I think we still need to fix. So we need this guy to go to his guard location, obviously, which is over here. Now one thing I wanted to do is fix it so that when he gets to his guard location, instead of just looking in whatever direction he was facing when he got there, he actually aligns himself with the direction of this object. My thinking being that I want it so that, like, say there's a door here, I wanted it so that the guard would look away from the door like he was guarding the door, and I wanted it to always have it so that the guard has a sort of set facing. So there's that thing to fix. We're already reacting to hear something. We're already doing the attack, so that's pretty much all we have to do to get the guard working. Now there are obviously a couple of things that I think we can fix to make it a little bit nicer. Obviously we could do better animations and things like that. But in terms of our normal functionality, we should be pretty close to complete. So let's just have a quick look at the behavior tree. So I've added an extra task type, which I'll show you in a second, called align to heading. And what that's actually doing is doing this when the character completes a path to move to this object. I actually call the align to heading to sort of say, make sure that you're looking in the same direction as this object as well. So what it looks like, if we just simulate, is that the character will come and look in this direction. It's probably not so easy to see here, but if I just make it look sort of that way. So we should look in that direction now, and let's just simulate that. And he just turns to look in that direction. It's a silly thing, but actually kind of feels a little bit more important, especially when he's coming back to this position after attacking something. So the other thing is that, strangely enough, the sight doesn't work either. It's almost like this character's just completely invisible, unless I possess something. And then if we watch the behavior of the character now, okay, that's not what I expected. I think something's gone wrong there. Let's just pause and have a quick look. So it turns out that there was some kind of minor problem with running the behavior tree nodes. I'm not entirely sure what's going on there, so if I just drag this guy out, you can see there is an issue somewhere in here with the logic of when he's attacked. But so what you'll see is this guy, when he goes back, will point in the direction he started off with. Obviously doesn't have to go to absolutely the same position. So what else is there? Okay, so the other thing is, when we're playing, I've added a system. If you see the sort of debug output in the top left, is that he can actually see an actor and not react to him because he knows that it's not an enemy. So we've got some situation where he knows what an enemy is and what an enemy isn't. So in this case, he's attacking that guy and not me because he knows I'm not an enemy. So that's it. That's our guard. He will guard our position and react to enemies now. And react to sound, unless somehow we've managed to not have a player control around, which is kind of weird. So let's show you first off how to tag a particular character as an enemy. So if you look at the character here, which is again an enemy character, you'll notice that if you look at any object in the scene outliner, the object should have a category called tags. And what I've done is I've added a tag called enemy. So, telephone, I won't be a second. So what we can do is we can just tag objects that we need to have the AI consider an enemy with a particular tag. Now obviously we can have a whole bunch of tags on this thing, so we can just add another one here if we need to. If you need the characters to react to different things in different ways, that's probably a good way of doing it. Obviously it's a little bit slow to do things like string comparisons and tags, but it's one of these trade-off kind of things, and I think it's a pretty nice and flexible way of doing this. So essentially my player doesn't have a tag to say enemy, which means that this guard character will just ignore him. So let's have a quick look at how the guard controller handles the tagging system. So if we go to the event graph for the guard controller, this is a little bit of a new layout. So what we're doing now is when we see a pawn, we've got this enemy tags array. Now if we look at the enemy tags array, and you can edit the array again, what we're saying is that there's basically an array of these names, an array of names. One of them is called enemy, and what we're doing is we're saying when we see a pawn, we loop through the enemy tags array and we execute its loop body. And in this case the loop body goes, if the actor has a tag with the array element, then we run this branch that's true, print a string to just say that we've seen something, set value as object like we did before into the blackboard. And here's the interesting thing, we call a custom event. So remember I talked about sort of adding custom events. I just created another event, custom event, called it break loop, fed that into the break input on the loop. What we could have done is we could have taken this connection and just dragged it straight into the break, but it just makes the actual sort of layout of the thing clearer. So we could have just essentially gone like this, but obviously the wire would look really hideous, right? So what we've done is instead we've called this custom event, which then feeds back into the break. So if it's not, if the actor hasn't got any of the elements, actually probably shouldn't do that there, because we'd get it for every single one of the arrays elements, but because we've only got one, it doesn't particularly matter. But I just print out to say, you know, which one of these branches I've taken. So all it means is that we're going to see an actor, loop through and look for any of the tags in our enemy tags array. Oops, I just didn't want to do that. Let's just delete that one. Loop through the tags in our enemy tags array, looking for whether the actor has that tag, and if it does, then we're storing it to say it's an enemy. Now we might want to actually store this object, rather than storing it in a blackboard, we might want to store it in an actors array. I mean, I've set that one up here, but we don't actually use it yet. But we might want to set up an actors array and then do some other logic to say which is the actor we should be interested in, we should be targeting. And I may do another video when we've played around with the mob AI to do exactly that, just to make it a little bit more interesting, because right now all this guard's going to do is see the first actor it can and go and target, which might not be the behavior you want. You might want to have sort of target the best threat or something like that. So we'll cover that in another video later on, once we've got some mobs to actually pose a threat, I guess. So that's for the C pawn. Here pawn's just as it was before, so we could probably do the same kind of thing. We could say if we've heard a pawn, ignore it if it hasn't got an enemy tag, maybe. As it is, I'm using the hearing sense to just sort of say, well, there might be something interesting over in a specific location, go and have a look. So in a way, you could do that. It's entirely up to you whether you think that that's a useful thing to do. So that's the guard controller. So essentially, we've just added this piece here to make sure that we're only targeting things that have the enemy tag on it. So I could, you know, in my player object, I could just add a tag that says enemy, and it would target me as well. It just gives you a way of filtering out which objects are targeted. So the other major piece of this work is, I guess, the specific kind of we go to the behavior tree, is this alignment node, this alignment task, sorry. So again, you just add a new task, give it a name. I called it align heading, or BTT align heading with actor. And let's have a look at what that code actually looks like. So it's a mildly complex one, but it doesn't really do an awful lot. So you add an event receive execute node, and it gives you an actor. I set this actor just so I can use it later on in other parts of the graph. You don't really need to do that. And again, I created a sequence because I might want to do a few extra things one after the other. So the first thing I do is I set the elapsed time to 0. So basically this elapsed time is going to accumulate over time, and I'll show you that in a second. So I reset it to 0 every time we receive an execute for that particular node. And then I get an actor from our blackboard with the given name, and I'll show you that in, well, if we go back to the behavior tree editor, obviously the actor to align with that name is set to the guard target. So basically we want to look in the same direction as the guard target in this case. Checks to see if it's valid. If it's not valid, it runs this sequence, which is essentially get the actor that we're controlling, cast it to a guard controller, get its pawn, get the pawn's rotation, and set that in a line heading. So a line heading is what's called a rotator. It's a variable that stores the rotation of an object. So what we're saying is, normally, if we've got a thing in our blackboard that we're trying to align with, we get it to transform, break the transform apart to get the rotation, and set the rotation into a variable. If we've not got an object, then we just take our own current rotation and store that in the variable. So that's the setup part, essentially storing the rotation to align with. And then this is the sort of interesting part. Let's just make that a little bit bigger. So what this is doing is, on the tick event, I'm running a sequence again. I like to do this just to give myself flexibility, and it just makes keeping the nodes a little bit cleaner. So in this case, you get a time that's passed since the last update as your delta. So what I'm doing is I'm essentially taking the elapsed time that we started off as 0, and I'm adding the time delta to it and setting it back. So essentially this updates the time with the amount of delta. So essentially we're accumulating time in this elapsed variable. And then the next part is the sort of interesting part. What it's trying to do is essentially take the orientation of our character that we're controlling, and we're going to try and interpolate towards the value that we're trying to align with. So I cast to the guard controller because that's the type of thing we're using as our controller. I get the yaw from the heading that we're trying to align with. Remember, we're only really interested in yaw, which is like our character orientation. We don't want to affect pitch or roll or any of that stuff. I then get the rotation, break that apart, and make a new rotation value. So essentially we've got the existing rotation here, and we're going to interpolate the existing rotation with our existing orientation plus our the yaw from our stored heading. So essentially we're saying make a copy of our orientation but change the yaw to the target yaw, and then we're going to do a thing called lerp, which interpolates between two orientations, two rotators. And what it's going to do is it's going to, if we set this to 1, it would essentially instantly take this value and change it to that value. But what it's actually going to do in this case is use the elapsed time, and what I've done is I've taken the elapsed time, which remember is accumulating upwards from 0, and I've divided it by rotate speed. So essentially I can scale how fast our character rotates, and it's going to interpolate between that angle and this angle by this amount, and you can check the box to say yes, choose the shortest path. So it'll choose the shortest arc around the circle. That will give us our kind of interpolated orientation, which we then set in the actor. I also print it out here. Just I'm switched the printing off, but I print it out there for debugging purposes. So I've set out the actor rotation. I also, what I do is I take another copy of that, I take the yaw, and I essentially say, is the yaw nearly equal to what we should be pointing towards? And if it is, so if we're essentially pointing in the right direction now, we do an if branch, and if it's true, then we finish executing this node. So what's really happening is that we're interpolating between two angles. We're interpolating the yaw angle between the character's current heading and the desired heading, and that's what this whole sequence does. It's quite a long sequence really for something so simple. So hopefully that's clear enough that you can. I'll just show you it again. Essentially it's interpolating the yaw angle using this lerp node. Lerp stands for linear interpolation, and it does it on the rotator. And then it does a check to see if we're at our sort of target value, and if it is, then we finish execution of this task. So essentially we just slowly rotate towards our target based on the delta time, and eventually we'll align with our target and we'll finish the execution of this node. Pretty simple stuff, but that's the kind of little detail I think is kind of worthwhile handling. So what else have we got to do? So we've made it so that our guard can attack things. We've used the tagging system to say that the guard can only attack specific types of characters, in this case ones with a tag of enemy. We've interpolated our heading so that we're pointing in the correction of the guard, in the direction of the guard target, not the correction. And we've made a test character that emits a noise and takes damage, because the player takes damage, so the copy of the player thing will take damage. So just to sort of remind you, the enemy character is essentially exactly the same as my player character that I'm using, but just without the user interface initialization stuff, because it kind of gets confusing when your user interface shows that your health's going down while he's hitting on another character. So that's actually quite a simple and quick setup, I think. I can't think of anything particular else that we need right now, and if we look at it, it definitely functions. So the guard will destroy that character. I suppose I could do an align. could do an align when he attacks as well. Maybe we'll save that for when we do an update to the character, the guard AI, after we've done some mobs, because that would be kind of interesting. And of course, no sooner as I finished making the tutorial when I decided that it wasn't good enough and there was something else that was missing. So this is just a quick addendum to what we already had. So if you remember our align with heading task, we basically had it so that it aligns with an object. Now, if we go back to the particular use case, let's just simulate it so we can see what's going on. Guard comes to here. For some reason he's not seeing this guy until I actually make him visible. So he hits him, and basically he wasn't pointing in the direction he was hitting him. He was still doing the damage and stuff, but it just didn't feel right. Right, so now he can turn in the direction that the character's facing. Just makes it feel a lot better. So I decided to, if I look at the behavior tree, I've got the align heading nodes for when he's going to the guard target precision, but I decided that what I would do is I would add an extra boolean onto that particular align heading task and say, if the boolean's true, instead of using it, instead of copying the orientation of the object, what we're going to use that as a sort of look at point to orient towards it from where our current position is. So what I've done is I've taken the setup and changed it a little bit so it gets the actor to align with, checks to see if it's valid, that's all fine. It says it checks that bool, which I've added as a variable. It says if we're using it as a look at target, or sorry, rather, if we aren't using it as a look at target, which was the only condition we used to have, it would get the transform, break it apart, set the rotation. So basically set what orientation we should be going. If it is a look at target, then what we're going to do is we're going to create an orientation by using this node find look at rotation, which takes a start and an end point. And in order to get the start point, there's this kind of chain of nodes, which is a bit crappy, but there you go. So remember, I set this actor as the incoming sort of actor that's controlling it. So it's basically the guard controller. So what I do is I take this actor, cast it to a guard controller, and the guard controller, remember, is an actor that's on top of a character. It's kind of not attached to it physically, but it's controlling a character. So what we need to do is get the character it's actually controlling, because it's the character's got the location in world space. So we get the controlled pawn, which is the character, get the transform for that, break that transform so we can get just the rotation. But in this case, we don't want the rotation, we want its location. So essentially it's saying, if we're using it as a lookout target, get its position in space and create a rotation value from it. Essentially from the thing that we're controlling towards the thing that we're using as a look at. So in essence, rather than copying the transform of the thing we're looking at, we're actually pointing towards it, and then we're setting that in the align heading. And I'm just doing a print string there to make sure I've actually got some values in it. So that's the change to our align heading task. And all it means is that when we're running the behavior tree, we can actually now reuse that task node to say we either align with the object that it's pointing to, or we use that object as a look at target for where we currently are and where we're supposed to be looking towards. So it's kind of a dual use task node. I've done it in the past where you've used two nodes, one for setting the angle and the other one for actually sort of doing the rotation towards it. And it just means, this version of it just means there's fewer nodes to worry about. So this is the blackboard. Obviously this is the go back to the guard point sort of overall override. This is the have enemy, move to him, look at him, play the attack animation, do the actual attack damage and wait. Whether we've got a noise, we just move to the location and wait and reset that when we've heard it. We could do something interesting here like wandering around, but we'll leave that until we've got some more behavior in the other characters. And then again, this is our just sort of by default go back to our location if we're not there path, move to guard location and align heading with the guard target. And then idle if we're not doing anything else. We probably could add to the idle and make it do some stupid animations and stuff if we add loads of those as well. So pretty simple setup for a guard, I would say. If you've got anything you want to add, if you want anything more with the guard, feel free to let me know in the comments of the video. Get in touch on the Unreal forums, send me a mail send me a tweet on Twitter, drop me an email, I don't know, pray to some deity of some sort that I could understand what you're wanting. I don't know. So simple, really, isn't it? That's the guard thus far. Now obviously we will revisit this guy once we've got a little bit more interesting behavior, something to fight him with basically. So maybe we'll need to add so that he can do things like ranged attacks, for instance, or he can do a bit more interesting searching. So right now all he does is he kind of hears something and goes to that position, and if he doesn't see anything then he'll just go back. What he might want to do is wander around a little bit and then decide to get bored and go back again, or something like that. So hopefully that's given you a good start on your guard AI, and we'll start on the mob AI next week. We'll probably start from sort of semi-scratch in that we might use some of these tasks again, but in general I want to start from scratch. We maybe use one of the Mixamo characters just to mix it up in terms of visuals and stuff as well, because it's kind of hard to see right now with everybody being blue who's what. So yes, this is definitely the end of the recording this time. Hope you've had fun following along, and let's go on with the next one.